Okay, look at this question. We have the matrix A is given, vector U is given, vector B is given, vector C is given. So we have a linear transformation is defined as AX here. So it asks us to find what is T of U. This is should be simple, right? So T of U is equal to A times U. So it's 1, negative 3, 3, 5, negative 1, 7 times 2, negative 1. So it becomes into 2 times negative 1 times so we can see this is going to becomes into 2 plus 3, right? 6 minus 5, negative 2 minus 7, right? That gives us 5, 1, negative 9. Okay, so that is T of U. So part B is find an X whose image under T is B. So you see for here 1, negative 3, 3, 5. So you have a 3 by 2, right? And then you want to have a AX, which is a 2 by 1. Such that A equals B. B is what? B is 3, 2, negative 5, right? So basically what we're looking for, the problem basically is led us to perform a row reduction, right, for this augmented matrix. So we can do that. 2 minus 3 times row 1 becomes row 2. Row 3 plus row 1 becomes row 3. 3, 3, and we have 0, right? So it's plus 9 is 14. So this is 2 minus 9 is negative 7. Okay, this is 0. This is 4. This is what is it? Negative. This is negative 2. Okay. We can do this. We can do use 2, row 2 over 7 become new row 2, right? We can use row 3 over 2 become new row 3. So just scale it. It's 1, negative 3, 3, 0, 2, negative 1. We have 0, 2, negative 1, right? Okay. So right now it should be good to go, right? Because 2 and a 3 are 0, so you can drive this 1, negative 3, 3, 0, 2, negative 1, 0, 0, 0, right? Use row 3 minus row 2 becomes new row 3. And then can easily solve this, right? So we can continue to do the reduce, which is can use row 1, right, to plus row 2 times 3 over 2, right, and then becomes new row 1. So 1, 0. So for here, so it's negative 3 over 2 plus 3, so it becomes into positive 3 over 2. So this part is 0. If I use row 2 divided by 2 becomes new row 2. It's going to be 0, 1, negative 1 over 2, 0, 0, 0. Hence, what do we got? We got dx is what? Okay. So that's the x we are looking for. Okay. Is there more than one x whose image under this T is B? The answer is no, right? Then the problem asks us, okay, if C is in the range of transformation T. This problem is basically similar to problem B, right? So basically we're looking for this 1, negative 3, 3, and then 3, 5, 2, and negative 1, 7, 5. We're trying to know that if this augmented matrix has a solution or not. Again, you do the reduce, right? Row 2 minus 3 times row 1 becomes row 2. Row 3 plus row 1 becomes new row 3. So let's see. 0. So minus this part become plus, right? So it's still 14. So it's nothing wrong with this one. Okay, so this part still is negative 7. And then, so let's add, so it's 4, this is 8, okay. Now, we can do some scaling. So, if we do row 2 over 14 become a new row 2, row 3 over 4 become new row 3, what do we got? We got 1, negative 3, 3, 0, 1, negative 1 over 2, right? And then we got 0, 1, 2 here, right? Okay, so if you try to use the row 3 minus row 2 becomes a new row 3, look at what we got. We got 1, negative 3, 3, 0, 1, negative half, right? So we're going to 0, 0. So it's going to become into a 5 over 2. And clearly, as you can see that from row 3, we already got a contradiction, right? Contradiction, because you have a pivot in the last row and the last column position here. Hence, there is no solution for this system. And hence the C is not in the range, right, of this T. So it's a force. Okay, so that's the explanation. Number 6. We also have a very teeny tiny one problem as the bonus. So it just said that E1 becomes this, E2 is this, Y1 is this, Y2 is this. So we have a linear transformation, okay, maps E1 to, so basically we have TE1 equals Y1, we have TE2 equals Y2, okay, and then it asks us to find the image of this guy. As you can see that those E1 and E2, those are actually, you see, if we list them together, this is a identity matrix, right? Matrix here. And also, since this is a linear transformation, so T of 2, 1, we can write it as T of 2E1 plus E2, right? Based on the property of the linear transformation, we try this as 2 as TE1 plus T of E2 here. And hence, you can easily drive this as 2y1 plus y2, which is 4 minus 2, right? So this is 4 minus 2 because 2 times 2 is 4, plus this one is minus 2, and then so it's negative 2 plus 3. So it gives us is 2 and minus 1. Okay, so that's it. This is something. Okay.